Notations used with counting techniques. If you've been reading in your textbook in Chapter 5, Section 5, you'll notice that there are 3 different types of symbolic forms for counting techniques. One of those is a factorial. This is usually used with the fundamental counting rule. And it looks like n factorial. The formula for n factorial is that you start with n and you multiply by the smaller number underneath it, so in decreasing order. If I start with n, I multiply then by n minus 1, then the next smallest number, n minus 2, and so on until I am at 3, 2, 1. For example, if I have 7 factorial, that means 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's a very large number that I'll calculate after I've gone over the symbolic forms. The next counting technique is a combination. In some textbooks, that's written with a subscript of n on the left of the capital C and an R on the right of the capital C. In this textbook and in many online resources now, it's written capital C, parenthesis, n comma R. Now the way both of these forms are said is the combination of n things taken r at a time. The formula is that you have your n things and you write that as n factorial over, so a fraction bar, r factorial multiplied with n minus r factorial. Let's come down to the example at this point. The combination of 8 things taken 3 at a time. That can also be written as capital C, parenthesis, 8 comma 3. In the formula, it's 8 factorial over 3 factorial multiplied with 8 minus 3 factorial. Now that also simplifies to 8 factorial over 3 factorial, 5 factorial. If we write out the factorials and what they mean in that factorial form, it's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. In the denominator, the 3 factorial is 3 times 2 times 1, and the 5 factorial is 5, 4, 3, 2, 1. Now I can simplify this when I'm doing it by hand. Usually I simplify by doing the 8 minus 3 factorial, which is 5 factorial. I can see that there's a factor of 5 in the numerator and denominator, 4, 3, 2, and 1. If I reduce all of those out, I'm left with 8 times 7 times 6 in the numerator and 3 times 2 times 1 in the denominator. And then I could simplify that further because we know 3 times 2 is 6, so we could reduce the 6 out of the numerator. That leaves us with 8 times 7 over 1, which becomes 56. So the number of ways that 8 things can be taken 3 at a time when order does not matter is 56. The reason that everything simplifies down to just 56 in this is because of the simplification that occurs in the formal formula. So n factorial, as we saw earlier, is n times n minus 1 times n minus 2 until you get down to 1. Looking at the r factorial, that similarly is r times r minus 1 times r minus 2 until you get down to 1. The n minus r is n minus r multiplied with the next smallest number, which is n minus r minus 1. And the next smallest number is n minus r minus 2, all the way down to the point that you get 1. So if I rewrite the numerator a little bit, I'm changing the middle phase in here so that it reflects the n minus r that would be occurring. And what happens is your n minus r reduces out, your n minus r minus 1, n minus r minus 2, and so on, leaving you with simply n times n minus 1 times n minus 2 until you get to n minus r plus 1, one more than where the n minus r started. And in the denominator, r times r minus 1 times r minus 2 until you get to 2 and 1. So that's a simplified version of the formula. for combinations. Now if we look at permutations, permutations are similar to combinations. Instead we used a letter P, and permutations are used when order does matter, so the values will be larger. The formula for permutation, you'll notice, does not have an R in the denominator. So when we clean up the formal formula, the n minus r reduces out, n minus r minus 1, all the way down until the 2 times 1, leaving us with simply the numerator n times n minus 1 times n minus 2 until you get to n minus r plus 1. Coming to an example, I'm using the 8 and 3 still. We're doing the permutation of 8 things taken 3 at a time. So using the formula, I have 8 factorial over n minus r, which is 8 minus 3 factorial. And that simplifies to be 8 factorial in the numerator, 5 factorial in the denominator, and then written out longhand-wise, you'll see the common factors of 5, 4, 3, 2, and 1 reducing out, leaving us with 8 times 7 times 6, which is 336. So we see that the answer for permutation that had used the exact same values as that for the combination has a higher value. Now, I showed you by hand just to help you understand the formulas and what you read in your textbook. I really want you to utilize online resources or your graphing calculator to solve this. So at this point, I am going to show you a website, and that website is mathway.com. At mathway.com, you'll see some headers or tabs, and I want you to select statistics. And then you'll notice that there is a symbolic form for combination and permutation. I'm going to use combination first and put in the value of 8 and the value of 3 that I had earlier. You'll see that it has a drop-down menu now of what you want to do with it, and it defaults correctly to find the number of possibilities. So you click answer, it calculates, and you'll notice that it says 56, which is exactly what I had on my document. A permutation, if I start over, I click, let's see, I need to start over, so click the X. Click P for permutation, type in the 8, 3, answer, and it gives 336. This is how I want you to use complete most of your problems. The other piece of information that can help you is your textbook. So at the end of the section for Chapter 5, Section 5 on page 217, you'll notice this section that says Incorporating Technology. And I sincerely hope that you've been reading your textbook and noticing these sections. In here it shows you how to use your graphing calculator. So I have my graphing calculator handy, and if I am to calculate the same problem, I want to do the combination of 8 things taken 3 at a time. I get 56. So going through the keystrokes for permutation, I type in 8, math, I arrow over to probability, down to number 2 for permutation, hit 2 or enter, and now I type the 3 and select enter. I have 336.